Hey everyone, today we are going to be talking about lesson 1.3, which is graphs of equivalent ratios. So we've been working with equivalent ratios for quite a while, and we've worked on scaling forward and scaling backward with equivalent ratios. And now we're going to put those things on the graph and see what that relationship looks like. So I have this little tiny check your skill section here for plotting points, just to do a brief review of how to plot points. I'm not sure why the lines are there because you're not going to write anything on them, but we are going to plot these points on the graph. I am going to label them according to the letter that is next to them in the question. So for 2, 4, I'm going to label it with an A, and then 0, 2, I'm going to label it with a B. So for point A, I'm going to go to the right 2 and up 4. So I'm going to call this A. For 0, 2, that means stay at 0 and then go up 2. So that is B. C means go to the right 5, 1, 2, 3, 4, 5, and then stay at 0. So that's C. And then D is over to 3 and up to 1. Now for plotting points, it's X, then Y, so left or right, and then up or down. In this situation, everything was going to the right and then up, and or staying at 0 and then going up, okay? Because we're working in that first quadrant, all those positive numbers. What we are going to work on specifically today is being able to create a ratio table following the pattern and then putting those values on the graph and then discussing what that relationship looks like and what pattern we should see. So in my first example here, it says tickets to the school play cost $3 each. The costs of 1, 2, and 3 tickets are shown in the table. So I can see number of tickets 1, 2, 3, and I can see the cost. We want to list this information as ordered pairs as the number of tickets X and the cost Y. So in my table, I can see the number of tickets, 1, 2, 3, and then I can see the cost. If I buy 1 ticket, it costs $3. If I buy 2 tickets, it costs $6. If I buy 3 tickets, it's going to cost $9. And this is just following the pattern of if I buy another ticket, I have to add $3 more. So my ordered pairs are going to be 1, 3, 2, 6, and 3, 9. Now on this one, you'll notice that the graph is not labeled yet. We are going to label the X with number of tickets and the Y with cost. So I'm going to put number of tickets down here at the bottom. And then I'm going to put cost in dollars on the side. And now I'm going to graph 1, 3, 2, 6, 3, 9. You do not have to connect these points. They are just standalone points on the graph that represent the cost of a certain number of tickets. We should notice that the graph appears to be a straight line, and they should be in a pattern that represents a line, given that it is an equivalent ratio table and graph. Part B is very similar, but now we're using a little bit larger ratio, and the graph you can see is a little bit different. So the bottom counts up by 2s, but every one in between is 1. So if you want to mark those, you can. And then up the side, you'll notice that it's going by 5s. That means that our values are going to be increasing very rapidly, and they may not fit perfectly, but we can still put them on the graph. So this says Ken's Home Supply sells fencing that costs $14 for every 3 feet. Generate the set of ordered pairs for the relationship between the cost Y, so I'm going to write Y, and the number of feet of fencing X, for a total of 3, 6, 9, and 12 feet of fencing. Now in this one, I can see that it's $14 for every 3 feet. So in my 3 feet box, I'm going to put that it's 14 feet, or $14, sorry, the cost is $14 for those 3 feet. And then every time I add 3 feet of fencing, the cost is going to increase by $14. So it's going to be $14, $28, $42, and $56. Now, if we do it like the first one, I can write this as 3, 14, 6, 28, 9, 42, and then 12, not 4, 12, 56. Now on the graph, again, I said we were counting by 5s up the side. Notice that none of these y values is going to hit perfectly on one of these numbers, but we can get close. It doesn't have to be perfect, but we can get close. So 314 is going to be right below 15. 628 is going to be below 30. 942 is going to be just above 40. And then 1256 is going to be just above 55. And I can still see that these points fall in a linear pattern, or they seem to form a line, and they should. When you're graphing these ones that aren't quite perfect, I don't expect them to be perfect, but I do expect them to look like a line. Okay. On to the next page. So now we're interpreting those ratio relationships along with graphing them. So this says to make 1 batch of homemade modeling clay that can be used in arts and crafts, Sequoia mixed the ingredients shown in the graph. So here is our table of ingredients. It says create a table to represent the ratio relationship for a total of 5 batches. And we are using flour and water. So from my table, I'm going to grab the flour and the water. So I've got 4 cups of flour and 2 cups of water. This is going to be 1 batch. So this is 2, this is 3, this is 4, and this is 5. If I increase my flour by 4, I have to increase my water by 2. If I increase my water by 4, I have to increase my water by 2. If I increase my flour by 4, I have to increase the water by 2. And I'm going to finish off my table. So I should have 4, 8, 12, 16, 20, and then 2, 4, 6, 8, 10. The graph is already filled in for you, so you don't have to graph it. I was just showing where the points on the graph came from. So this is your 4, 2. This is your 8, 4. This is 12, 6. 16, 8. And then 20, 10. Okay, so there's the points on the graph. And now we're going to describe the pattern in the ratio relationship. The first thing we're going to describe is what the graph looks like. So we're going to say the graph is a straight line, because I can see on the graph that it is a straight line. And then I'm going to say that the relationship shows that for every 2 cups of water, there are 4 cups of flour. Because when we describe our ratio relationship, we want to describe it as if the fraction were written. And in this case, the fraction would be 2/4, the comparison of water to flour. The next part says this means that the number of cups of water increases by blank cups as the number of cups of flour increases by blank cups. So you can see that I have it in the correct order with water first and then flour. And what they want in this part is if my ratio is 2/4, what is that simplified ratio relationship? So here I'm going to divide both the top and the bottom by 2, and I get 1/2. So as the number of cups of water increases by 1, the flour increases by 2. I could also just continue to use the 2/4. Okay. So I could use either one. We like to write our ratios in simplest form, so I would err on the side of using simplest form. Part B says to make 1 batch of nectar to feed hummingbirds, Melanie added 4 cups of boiling water for every cup of white sugar. Create a table to represent the relationship for a total of 5 batches and graph the relationship. So I've got white sugar and I've got boiling water. And I am taking those pieces of information off my graph to put them in there correctly. So here is my refined white sugar in the X column, and then I've got my boiling water in the Y column. So this is X, this is Y. And then it says to make 1 batch of nectar to feed hummingbirds, Melanie added 4 cups of boiling water for every cup of refined sugar. And every cup means every 1 cup. So now I'm going to continue my pattern. So the white sugar is going to go up by 1s, and the boiling water is going to go up by 4. So now I'm going to put these values on the graph. These ones actually fit on the graph pretty nicely. So 1, 4, 2, 8, 3, 12, 4, 16, and 5, 20. So to describe the pattern in the relationship, I'm going to do something very similar to what I did on the last question right here. And I'm going to describe this graph as a straight line. So I'm going to say the graph of the points is a straight line. And for every 4 units up, you go 1 unit over. So that's another way to describe what is happening on the graph. So when I go up here, I'm actually going up 4 units. Okay, so here I'm going up 4 units over 1 unit. Up 4 units over 1 unit. So that's another way to describe it that's not using the actual wording from the ratio relationship. So up here, I said that for every 2 cups of water, there are 4 cups of flour. Down here, I'm describing literally what the graph is doing. It's going up 4 units over 1. So those are both valid ways to describe the situation. And this means the number of cups of boiling water increases by 4 for every cup of refined white sugar. So I am describing the fact that the number of cups of white sugar is going up every time I add a cup, or the cups of boiling water is going up by 4 every time I add a cup of refined white sugar. So both of these are good ways to describe what is happening on the graph. The first one, I used everything that had to do with the units and everything that was in the problem already. Down here, I described it as what is actually happening on the graph, literally as I'm looking at it. So I was counting up 4 units going over 1, and that describes the ratio relationship. These graphs should be a straight line. So when you are graphing, you should see a straight line every single time that you are graphing one of these. If you are not, then there must be a mistake in the actual graphing portion, because they should look like a straight line. And then when you're describing the ratio relationship, you should be describing what is happening on the graph and how is that related to the actual ratio.